Hello. We are going to graph a couple of lines together on the same graph, please. So make an X and Y axis, and these are both in slope-intercept form, so this is good review. The y-intercept is the constant in each one. So in the top equation, it says half x plus 3, so my y-intercept is the positive 3. So I'm going to go ahead and graph that on the y-intercept, and then my slope is 1/2. Remember, rise over run. So up 1, right 2. And I'm also going to go down 1, left 2 to make it a little bit longer. And that didn't come out very well. Okay, so there's our line for the first one. Do the best you can, as I will. All right, my second equation, half x minus 4. So my y-intercept is -4. And my slope is up 1, right 2. Or down 1, left 2. So same slope, as you noticed. And you may have already guessed that these are going to come out to parallel lines. So if I did the same exact slope, those lines are going to be slanting the same degree or in the same direction. They're both increasing. They're increasing by the same amount as we run the same amount. So you can pick any y-intercept that you wanted to. So if I asked you to write me a third equation that would be parallel to these two lines, you think of your own y-intercept. So it could be y equals 1/2 x plus or minus just about anything you could think of besides 3 and -4. So they have to have different slopes. So again, still talking about parallel lines. They have to have different slopes. Same slopes. Different y-intercepts. So those are the two rules. Okay, we're going to do another graph together. So find another spot on your graph paper. And we're going to graph these two lines. So the first one is -3x plus 2. My slope is -3 over 1. So if I rise 3, I'm going to run to the left one. And if I decrease 3, I'm going to run to the right one. And for the second equation, my y-intercept is at -1. And I'm going to rise 1, run 3 to the right. And my whole goal is to get these intersecting, which they already are, but I'm still going to put another point in the other direction. If you drew your lines better than I did, I hope you did. It's hard to do on the screen. Sorry about that. If you did those lines straight, you can test the angle with a corner of a piece of paper, an envelope, a folder, anything that has a right angle. And if you put it in to the center, kind of test out right there, you'll see that these two lines make a right angle. And hopefully you remember that that is called perpendicular lines. So we talked about parallel lines that never intersect. Perpendicular lines intersect and they make a right angle. What I want you to do is go back and look at the two slopes. So our top slope was -3 over 1. Our bottom slope is +1 over 3. And hopefully you notice by looking at those that they are reciprocals. Those slopes are reciprocals. And there's another very important factor besides being reciprocals. The slopes are also opposite signs. One of them has to be an increasing slope while the other is a decreasing slope. So sometimes we say that as just opposite reciprocals or negative reciprocals, just meaning that one's positive, one's negative. So those are the rules for having perpendicular lines. If I asked you to give me an equation of a line perpendicular to negative 2/5 x plus 7. In this case, when you're talking about perpendicular lines, the y-intercept makes no difference. They can be the y-intercept, they can be different y-intercepts, because these lines are not going to, it doesn't matter where you start them. But if I asked you to write me an equation of a line that was reciprocal to this, all you need to worry about is making a new slope. So the slope has to be the opposite sign and it has to be the reciprocal. So I could say, okay, y equals positive 5/2x, and then I would just make up a y-intercept of anything I wanted. If I graph those two lines on the same graph, then they would be perpendicular lines. So I'd like you to go through these 5 examples, and don't worry about writing a whole equation, but let's just figure out what the slopes would be. So tell me, if I was to write an equation for each of these, what would the slope be? What would my new slope be if they were to be perpendicular? Parallel, we would have the same slope, but let's do some perpendicular slopes. So pause the video if you need to. So for the first one, if y equals positive 2x, my slope is positive 2, the perpendicular slope would be a negative because the first one's positive, and I would flip it over. Second one, my slope is negative 2/3, so my perpendicular slope would be positive 3/2. Third one, my slope is 1/1. Perpendicular slope is also 1/1, but it's negative 1/1, or just -1. The fourth one, y equals 8. If you remember from graphing, the slope on this is actually 0. Because if I graph this line, it's a horizontal line. So if my slope is 0, 0 can come from doing 0 divided by any number besides 0. So 0/1, 0/2. But if I flip that over, I now have a 0 in the denominator. So if I have a horizontal line, what's perpendicular to horizontal lines? Vertical lines. So this one is very special because it's just an undefined slope that would be perpendicular to it. The last one, x equals -4, those were tough. That was also from back when we started graphing a couple of weeks ago. That is a vertical line, so it's the opposite of the one before. So if it's a vertical line, x equals -4, that means its slope is undefined, which means a horizontal line, which would be perpendicular to it, would have a slope of 0. So all of these slopes off to the right, these are all of the perpendicular slopes.